So this is AI native RAN, just like cloud native, whatever is cool, you add native to it, and then, you apply it to some object, right, that you want to make cool again. And so you said AI native RAN means RAN has to be cool because AI is cool, right? The problem is I have no idea what AI native RAN is, but I know someone who actually has a definition, and he always gets the right answer. So I'm going to set him up, just like Anand set me up, I'm going to set Kiran up here. So what defines an AI native RAN, and how does that differ from just using AI on an existing RAN architecture?
Thank you, Roy. Maybe as a quick word of introduction, Kiran Mukavini, Qualcomm Wireless Research. I lead our systems research in 5G Advanced, 6G, IoT related things. But I'm glad you're starting off with this question, because at least we'll have a context here, because otherwise each one will have a different definition of what AI native RAN is, and we'll all be talking and we'll all try to match it up with, wait, that does not fit with what I'm thinking of AI native RAN. So this is at least, maybe it'll just get down to an hour of debate of if the definition is right.
That's okay.
And but maybe okay.
Debate
Because at least
here. That's okay.
Yeah, we can go at least walk out with maybe a definition or not so accurate definition. We'll see. But at least, the way we look at AI native RAN, first of all, AML is not new in the context of RAN. And sure, then we have all been seeing about use cases. Someone has talked about this even 20 years back. You were doing something and now you realize, okay, AML is trying to do maybe a similar thing in a different way, or maybe slightly more sophisticated, more data that's available and all that. So just taking a step back, yes, we have had it for a while. We have been doing it on the device. We have been doing it in the network. We have been doing it on the RAN. And it's been happening in somewhat of an independent fashion between these entities. And then 3PP came along and said, maybe 5G Advanced, release 18, release 19. Let's do this in a more coordinated fashion. Is there something to gain? If the device knows what the network is doing, if the network knows what the device is doing, they work hand in hand, what can you get out of that? And there's some use case that we studied, and I'm sure we'll touch upon that as we go along. Channel state feedback, beam management, positioning, and related things. So that came along. Is that good enough? Does that make it AI native? And at least our way of looking at this is no, not yet. So this is one step in the direction, but really when we talk about AI native RAN or near interface, what we're talking about is designing the entire RAN or AI interface ground up, keeping AML in view. And what that means is bringing AI/ML algorithms into every layer, every component, and not really designing each use case separately, but then thinking about the sum totality, thinking about how optimizing and designing for one use case impacts a second or a third or fourth use case. And as you start looking at some examples, it starts to become clear that even, 3 big examples that I talked about, channel state feedback or positioning or beam management, they may use different reference signals right now, but inherently they're all related. The kind of feedback that you're looking for can make it a bit more comprehensive and then actually cover all 3 use cases together. But then that's just at the physical layer. But now if you go up one layer higher, even from a scheduling point of view, then one layer higher from a mobility point of view, a lot of these use cases start to come together under the same umbrella. And if you can take that into account from day one, and then make sure that your design overall at these different layers and components is able to do that, is able to optimize different use cases, different device types, different network conditions for all these different scenarios. And if there is an ability for the air interface to do that, for the RAN to do that, we consider that a native RAN.
That's fair. That's pretty deep, right? You go all the way down and all the way up. So the answer can't be wrong, because if you have AI and every layer,
every box is checked,
all the way to the AI ops will add the operational as well, right?
Yeah. So
then that has to be AI native.
That will be AI native telco. At that point, AI native telco, but we are just operating at AI.
Then we keep going up to customer service, and now you have an AI native telco.
There you go.
That's the growth. So. So I see some shaking heads, but we'll let you talk.
Hopefully nodding, no shaking.
You can all shake your heads too, by the way. I mean, I think that's a signal to currency. But thank you. That's helpful. Now, AI native seems to be a goal that we want to go after. At least, if we talk the whole day and we're like, oh, AI. It seems like the goal that we're trying to achieve. But again, AI isn't always the answer, as we know, right? And someone who's not a troublemaker but can be contrarian is is going to be Sridhar, and he's going to talk about the fact that, we've talked before. You're like, AI is not always the answer, Roy. And you said that before. Right? I think literally you've actually said that. And then maybe you can describe on what are the approaches, right, that makes sense, could outperform AI in RAN, specifically because you're talking about a RAN. And how does that shape your own view of AI in native RAN, which I know may be slightly different from Kieran's. So, but go ahead, introduce yourself, and then you can answer that question.
Sure. Sridhar Rajgopal at Mavenir, responsible for access technologies, which includes RAN, radio, and RIC aspects. Regarding this specific topic, my view is that when we design communication systems, let's see how they were actually designed in the first place. We go to first principles, right? I mean, there is some information theory and communication theory behind it. Sure. So there's a transmitter, there's a receiver, there's an unknown channel, and all the signal processing and stuff that we are trying to do is trying to correct for these issues that we see in the channel. So you come up with, algorithms, which are again, has some very strong mathematical foundations in terms of taking time domain to frequency domain, correcting for errors. I think the reason many times you're not able to achieve what you call as capacity in some sense is because of lack of knowledge, because that's all we are trying to correct. So we want to do how to get to the best bounds and compensate for the lack of knowledge. Now, the lack of knowledge is, you try to correct for it by adding things like pilots. You put some training data in that to actually correct for those errors that you can get, and you put some redundancy in the data to actually do some error correction based on that. Now, where AI/ML can actually help is because since when you're adding these pilots or adding this redundancy in your system, it impacts your overhead, because the more training you do, the more overhead you do, and you don't have time because all these items are having real-time constraints. You have to do certain operations with certain amount of time, and also the algorithms that you may have, you may know what is the optimal algorithm to do, or at least you may have an idea of getting close to an optimal algorithm, but you have real-time constraints that you have to meet, so I'm not able to process all that. So because of that, with finite data and finite training, I'm only able to do so much. But if I have history, and if there are certain things that I can do where instead of just looking at the current instantaneous item, if I can look in the past, I mean, that's where things I can make use of history, like, for example, channel estimation, or things like beam management. For I know in certain direction there's a wall, no point in sending a beam over there. So I think those are the areas where I can learn, or I know certain time of a day on Saturdays at this time there is no traffic. So there are things that you can do to optimize based on AI. But things that, for example, taking a time domain transform to a frequency domain transform, I mean, it's a mathematical operation. I don't see any need for AI. It's like I want to do 5 plus 3. I don't need AI to do that. I mean, it's a mathematical.
Actually, AI doesn't do that. It writes code to do that. Yeah. AI is smarter than we are. They know.
Anyway, so on that topic, I mean, just to add, see, even if you have AI, the other comment I want to make is, AI is all about data. So as long as the data is valid and it meets what you're trying to achieve, it works very well. And you can get all the additional gains because of all the knowledge that you have accumulated from the past. But again, we are building a telecommunication network. Mm-hmm. Operators, I mean, there was discussion right in the panel before. I mean, very sensitive to anything going wrong. So you don't want to have any chance of making mistakes. And so if for some reason something has changed in the system, either somebody added a new site or somebody did a software upgrade and you have new features, so the traffic profile changed, environment conditions changed, somebody built a new highway, whatever it is. You want to have fail-safe mechanisms, you want to have guardrails,
sure,
and you want to have backups, you want to have plan B. Yep. So if AI doesn't, so there is still a place, even with the AI world, you still have a place, there's a place for
rules-based algorithms,
heuristics, yes, rule-based, mathematical processing, domain knowledge to kind of do the best processing you can. So that's the second point. And the last point I want to make on this topic is, see, one of the reasons many of the algorithms fall short is because of real-time constraints. I have to do certain things fairly quickly, and I didn't have the compute resource to do that. But now, with 6G, now we have more powerful processors. Intel is coming up with AI in their chipsets. We have alternate technologies
Like the other company.
That other
I'm not
company
talking
that
about
Anand talked about. So we have more powerful compute. So of course you can put AI on that and do that, but you can also implement more sophisticated algorithms that you could not do before. So the actual, in my opinion, apple to apple benchmark would be to take the next generation of powerful algorithms from mathematical principles that you can do, and then compare it with AI. I mean, that is the fact, because they are running on the same hardware, and then you do the comparison. So I think there is a space for AI, but I also believe that there is space for alternatives to AI.
I think that's fair. And we know where it's going to go. Yeah, go ahead, Karen.
Just to make a note that none of the conflicts or contradicts the definition of AI native RAN. It all supplements and
Actually, so
it adds to what's here.
it's all within the umbrella. It's all within. Yeah.
So and you know where it's going to go. Eventually, you're going to call something hybrid, because hybrid cannot be attacked, right? Because you're going to have, right? I mean, hybrid or multi can never be attacked.
it's called all-inclusive.
All inclusive, yeah. The DEI word. I'm going to call it the DEI RAN now. That's a good word. Yes, this is a bad word right now, but yeah, the DEI RAN, right? Which is good. The hybrid, right? You're going to have AI. We welcome AI. We welcome algorithms. We welcome heuristics. Whatever whatever helps the RAN, we welcome. Good.
But I don't think anybody always wanted to apply AI everywhere. So I think it's not about where it shouldn't be. It's more about where it should be.
Yeah, the right tools for the right.
Yeah, exactly.
It's multi and hybrid,
And,
always wins.
And if you are able to improve any KPIs or not, why do you do that? Have you improved spectrum efficiency or some other performance?
Yes. Yeah, I mean, again, it's got to give you an outcome. Otherwise, why would you put it?
Yeah.
Unless you want higher valuations, right? Then you put it in there.
Yeah,
Like, I'm an AI CSP, I'm an AI MNO, right? My valuation should go up now, right? 15x, whatever.
No, also just to maybe give another example of why I think what I was saying is complementary is, I think in the past AI has been used for maybe tuning parameters. So you can tune parameters in L3, it is called SON. You tune parameters in L2, you can schedule, the scheduler parameters can be changed, priorities can be changed. So, but I think those, when you call about parameter tuning, which is using some configuration parameters, I mean, so that in my opinion is AI assisted. It's not really
AI assisted algorithms,
Yeah.
right? And AI can come up with new algorithms too.
But if you're building like a neural receiver or something, or putting in your system, and it's actually doing the training and processing and doing inferencing, I think to me that is native AI.
It's fair. I think that's fair. Now, I mean, so we know the word AI native RAN is not going to go away. AI RAN is going to stick around. I think that's a reality. And the industry is going to try to establish alliances and standards and frameworks and all that. And let's talk about the industry in terms of AI native, right? So what are we seeing in terms of the momentum around these industry initiatives, and what are they trying to achieve? Because we brought up one earlier today. I think someone brought up AI RAN Alliance as an example that we've all heard of, probably, right? There probably are others, right, out there. And maybe, Jalka, based on your background and your understanding of sort of the ecosystem, what's happening out there and what are they trying to get to? And before you begin, just introduce yourself.
Sure. Jalka Master. I'm head of Global AI Accelerator US. We have different locations in Europe, in India, in Canada, in US. So this is one in US. And in terms of alliances, in Ericsson, sorry, I meant to say part of AI Accelerator at Ericsson. So in terms of alliances, I see this gathering as kind of mini alliance. It's not permanent, but it's at this moment, during this time, we are talking about people who are in ecosystem, exchanging similar problems, talking about similar challenges, and seeing how to overcome. So that's kind of what we see as part of forming those alliances. You have alliances which are talking about how to create best telco LLM, and use the alliance to exchange data and contribute to building such LLM, Anthropic, and stuff. And then you have AI and RAN Alliance, for example, where lots of players are trying to get together to see how can we solve some of those problems we see. We all want to optimize network, and we see similar challenges. So how do we create the reference implementations? How do we create test scenarios, test cases? How do we create labs where we can test it using real data, using synthetic data, and all benefit? And also at the end, how do we make this adopted? Because many times we create best algorithms, but when people are scared to use them, like to your point, like what will happen, like this anxiety about will AI change too quickly, some configuration parameter, will network just collapse? So this is that where whole industry comes together and say, okay, we tested it, we all tested it, we stay behind it, and let's implement it. So it kind of helps with adoption, and then also helps with evolving the infrastructure on which those algorithms run. Let's say Intel, generating better and better processors, which we all put like test, and then maybe they become cheaper, and they're less custom for one operator or one entity, let's say like Ericsson. So those are kind of all benefits of such alliances.
Yeah, I think that's fair. I think so far we've seen a lot of movement, a flurry of action, because I think everyone wants to jump on the bandwagon. And but I think it's fair. I think the goal is no company can go it alone. I think that's a reality. And the more we share the practices, the more we share the learnings, to a certain extent, because there's going to be some proprietary stuff in there and everyone wants to win. But to the extent that we share that, I think that is in fact useful. And so I think that's good. So let me check with the audience to see if anyone disagrees so far with the definition, which is, the comprehensive definition of AI native RAN. And sort of I think the role of the alliances, no one's going to debate, right? I mean, look, we're here at the Aira Alliance meeting, the first one, right? So you're all here, so it's got to be a good thing anyway. Yes? We still haven't heard from two of the panelists. Yeah, we will eventually. Eventually. I'm holding the best for last, just so you know. Eventually. So we're going to progress our journey through. We're going to start with the definitional, because again, like, what is an AI native RAN? And we decided that AI native RAN is exactly what Kiran said, because it's definitive, but does not contradict what Sridhar said, right? So, which is good. It's robust. Your definition is robust. It's withstood 15 minutes of tax so far.
Standing the test of time.
Yeah, 15 minutes. 15 minutes so far, so good. So far, so good. And then what we'll talk about next is sort of the architecture. We'll talk about other aspects of the AI native RAN. Hopefully, we'll get it a bit deeper, because I know a lot of the topics that we're talking about were covered earlier. So you've been here the whole time and paying attention, unlike me, that you would have said, they said that already, right? So we're trying to actually have new material for you and new learnings and new discussions for you. I mean, that's the goal. But so far, so good. All right, good. Let's talk about the architecture and implementation approaches of an AI native or hybrid or multi-RAN, whatever it may be. I know that Kiran started talking about the layers. I think layers are always a good thing. We like cake, right? So layers are always a good thing, especially T-Mobile's here. Layer cake is always a good thing, right? So maybe let's have the official mischief maker define the different layers of the stack where AI can make an impact, from foundation to operation in more detail, because I think Kiran showed some of your talking points earlier. But I'm confident you can make new ones up that better. Come on, Udaya.
Kiran can do the whole thing.
No, I mean, I didn't tell him to do it. I think he listened to you the last time. He's like, let me take notes and let me just repeat things.
Better last time.
Yeah, exactly.
Maybe you should have asked what is the progress from last year.
From last year to this, actually, we can ask everything.
So, Udayan Mukherjee, the mischief maker from Intel, I did all the product architecture as well as standard for wireless. AI essentially is nothing. The foundation model or the Gen AI portion is been added recently, but the foundation stuff, even the stuff we are doing, if you go by layer, this morning the AT&T talked about a lot of power management. If you take a foundation, if you take a system and foundation, you have a lot of hooks in the silicon right now, but you are not taking advantage of it. For example, sleep state. It can track even within the TTI, your utilization varies quite a bit. There are lot of times there's nothing going on here. So why am I actually spending power into this? So if you don't do AI, what you do right now, you leave it to OS governor. Governor takes his own time and then transfer to different sleep state. His processor sleeps has been there for the last 4 or 5 years or even more. Cloud was taking it. 20 years. Well, but yeah, so we have improved quite a bit. But no telcos used to just turn it off in the BIOS. They want deterministic system, but you can still get deterministic power. Now AI is being utilized on those aspects of it, and your application can be smart enough. your DU application conversion. So foundation, sleep state, P state means every core. When the 20 years back, when Anand was designing some of these things, he didn't have any clue that every core you can manage. It's like taking a package of like, okay, whatever, that way you did a code. But the monolithic, either you transition one step or now you have a 64 core platform. You can do every core into different frequency, lower frequency with lower power, sleep states. So all of this, we are heavily using AI, and it doesn't have to be a foundation model. CNN, JNN, many of those aspects of it that we are using. So that's the foundation side of it. And I think there's some demonstration that AT&T guys showed in the last MWC, the February in Barcelona on this. Then you go up on the system in DUC. DU, couple of examples that Kiran Tato, that's 3GPP started with beam management and CS had some of the other aspects of it, but every aspect of it, channel estimation, my MMSC or MLD has not changed for years now. Can you improve those? And then you experiment on this and see if you can improve based on a baseline, not taking a crappy implementation, but take a baseline and say, hey, I can improve my saleage performance by using AI. So every layer of the layer one, there's a lot of opportunities. And I think you guys are doing certain things that are already, there are a lot of innovations coming in. Then scheduler. You go up in the scheduler. There are a lot more work can be done on scheduler, rake, near-term rake, and a lot of aspects can be done, can be developed. But then you wrap it up with some form of Gen AI for operations. There are a lot of utilization that people are asking for a pilot model for operators, and then this is where you can use a Gen AI model, like you guys are doing RAN-GPT and stuff like that. There are now different ways.
Not RAN-GPT anymore. It's now.
Okay, now is the navigation.
I just renamed it. Exactly.
Yeah. That's a change from last year.
I know, that is the one change.
So what happened there last year to this year, just to add to this, there are many of these experimentation going on. I was in Iran yesterday. Interestingly, the operators are still asking questions on how much AI I need. An operator directly asked me, how much AI you need?
$3 million. Your answer is $3 million worth of AI is what you need.
And how are you making sure processor is AI future proof? Well,
you just use Intel, right? So
but I think a lot more questions are being asked. A lot more people are getting into it.
Yeah.
There are still we can talk about some of the earlier discussion in the panel talk about network APIs or programmable APIs. There are certain things we can do there to expose so that somebody is coming up with a AI-based and the next generation of MMSC can plug it in the overall stack coming from, say, Ericsson or Samsung, which is not there today.
Fair. That's not there today. The guardrails are not there today.
Yeah, then you still a monolithic block.
Yeah.
So but I think those things will open up.
Yeah, I think that's fair. I think in terms of the layers, there's a lot of. I think what you're saying is there's a lot of things to be exploited still that we haven't exploited.
Oh
yet. And maybe AI can help expand the possibilities of exploitation, just like it helps us all write code much faster. It can help us exploit those things much faster. It can exploit much faster if we can put the guardrails in, and we'll talk a bit about that later on.
One other point you asked about that, what are the efforts? AI run is one. TIP has started a telco AI kind of a model.
Yes.
More than RAN. Yes. It's a system-wide view. There are core, packet core and all of this. So that's another effort. And a lot of these same players are there.
Yeah, I think that's fair. And next week is Fuse on Monday, Tuesday, and Wednesday, and some of y'all are going to be there, right? So I think it's another place we can have another discussion about the AI native RAN, whatever that is. So,
now we know.
Sorry. Now that we know what the AI native RAN is, definition, there's no question anymore. Sorry, that's been laid to rest. I have a definition. Now, I know earlier, I think Raj said, there are no low-hanging fruits, right? But there are low-hanging fruit. Well, okay, let me ask you. So you've been working on AI RAN for a while, clearly, given what you focused on. You work with a lot of telcos, worldwide tier ones and the like. And say there's no low-hanging fruit, but what are the medium-hanging fruits that you see, Ravi, out there? Maybe not low, right? But medium hanging fruits that are possible with the RAN today? What are the ones that the carriers are most excited about, and what do they feel the most comfortable doing that you see?
Yeah, just for introduction.
I don't think anyone knows you in the room, so you should reintroduce yourself.
I'm Ravi. I'm co-founder of Aira Technologies. And yes, like Troy mentioned, we have been working on applying AI to the RAN space across the layers, right? We showcased Navic, but we actually started with a lot of stuff on layer 1, layer 2. And when we started, to answer some of the previous questions, a lot of the core team were information theorists and coding theorists, right? And we were using AI, like to Sridhar's point, why are we not developing better information theory algorithms? So the way we were thinking about it or looking at it was AI is a framework that can be applied across the layers, right? If you can form a problem in a way that a standard AI block can solve, there aren't too many AI blocks. There's CNNs, the LSTMs, GRUs.
Yeah.
So if you can form the problem and set it up in a way that the AI optimization backprop can optimize it, then it allows you to operate across the layers. Just to give you an example, even within layer 1, there are blocks. There are so specialized kind of knowledge information that's required to optimize channel estimation block versus optimizing a coding decoder block versus optimizing the scheduler block. Previously, these were completely separate PhDs. This guy wouldn't know what that guy was doing. That guy wouldn't know what this guy was doing. They wouldn't talk to each other. This guy would think that guy's work is trivial. This guy would think this guy's work is trivial. So now we are coming up with a framework where
There's nothing personal there, right?
That's
Not for personal experience. It's just what you observe.
I'm layer 1, so everything above that is trivial. So, so we had started thinking of this as a common framework. And to Sridhar's point, the other paradigm
You have to
shift
quote
in-
Kiran at some point, by the way.
Yes.
Just keep pointing at him.
No,
And in agreement.
yeah, so we are in agreement. So coming to, like, for example, once you set it up, so the second slightly paradigm shift is, I think we hold AI to an unreasonable standard. And let me tell you what I mean by that. So when you move from, let's say, C to C++ or C++ to Python, you weren't expecting 10% gain in whatever dimension because you moved from C to C++. You moved because it was a more holistic approach. It made coding easier. It made thinking about the problem a little bit easier. So that should be okay as long as it doesn't degrade, as long as it doesn't kind of
Has to do
break down the problem. Just the fact that you can use a unified framework across the layers is benefit in itself. But on top of that, we have realized that there are certain blocks. So far, an AI-based LDPC decoder isn't going to work. Isn't going to do better than your standard message passing or whatever. But there are certain blocks where AI is showing promise. And to finally getting to your question,
Yeah, the question.
which is, where are those kind of medium hanging?
Yeah, yes. We don't talk about
So one of the things is open loop, right? What do I mean by open loop? Like designing better constellations, designing better air interface. So you can do all the design in a separate environment and prove through standard bodies that here is a code, I found it using AI, but it's going to be defined, well-defined, and it's going to be fully characterized. Just use it. How did I find it? Doesn't matter. Once it's defined and once everybody can use it, they can use it. So that's one place where I can see a lot of profit gain, and it's non-controversial.
Yeah.
Right.
Yeah.
No
It's like
people
code
are-
unfolding, right? Once you discover, you can use AI to discover. what you're
Discover better codes,
Yes,
discover better
exactly.
constellations, and maybe you can switch between. You can also say, depending on
Learn
the
when to
conditions,
switch.
you can
Yeah,
switch.
yeah.
So all of those, I see that happening. Optimization has already been touched upon, where I see a lot of parameter optimization, lot of optimization on some of the signaling and pilot signals that are being sent, there are hooks to optimize it, but using those hooks optimally is not easy.
Sure.
Like, yes, you can send SRS in a million different configurations, but how do you really choose the right configuration? Most operators set a configuration and forget it. So how do you choose it? And how do you choose it on a per UE basis? How do you choose it on a per band basis? So those are all places where we see medium level
opportunities.
opportunities. But yeah,
Thank you, son. That's helpful. I see that.
Just one ad that talks about framework.
Yes.
If you ask Ericsson's of the world or Samsung's of the world, cross-layer optimizations has been done for years. They have optimized and it's not just monolithic block. They're looking into pre-coding to channel distribution, SRS-based channel distribution versus DMRS-based, whatever. There's across the elements of it. Now, if AI can improve this thing, simplify it without adding power, cost, and everything, great.
Yeah.
But if you're just doing it for I'm going to create the framework, you have to show some benefit. The reason for getting from C, C++ to Python, that it showed benefit of simplifying overall aspects of it. Yeah, and it's in the same way to simplify or improve the KPIs.
So maybe just to add one other point to that, and because the question arises, how much does AI have to do to prove itself to be better than what's already out there? And just being able to do what was possible otherwise, maybe a bar a little too low, just because the question that comes up from operators a lot of times is, if I'm able to get the same functionality, do I have to support my legacy as well as this? Is it
Yes.
am I multiplying? Is this 2x the cost for same functionality? I think that's really the challenge at this point. Unless the cost comes down so much, or we are able to say that this particular way of doing things can completely replace. You don't have to worry about it.
So that's where I think I agree with you that the hooks need to be there. Any block should be implementable via AI, but it's really up to the whoever is making the receiver to decide, hey, this block I'm going to keep traditional. This block I see gains. I'm going to replace it. But yeah, having those hooks and having those signals be as long as you're thinking about, hey, maybe this block might be implemented by AI by somebody, and you keep those hooks available and make them visible.
That's the key, right?
I
The
think
model, componentized model, right? That gives you the ability to innovate, sort of in modular blocks and across blocks with unified APIs, right? So that you can move across. I think that's the key. I think that the difficulty is, if monolithic's not going to help us here, right? Whereas a componentized model allows you to incrementally go after each of those pieces individually and potentially, as a whole, right? Potentially. So I'm going to move us along here a little bit here and talk a bit about something that we haven't talked about much because, we haven't had device people up here. Talking about AI native RAN, which is not, the RAN is part of it, but the UEs are also important as part of that. How do you see the interplay between sort of the UEs and sort of the RAN infrastructure? And what's the role of AI? And I'll start with Kiran first, right? And then I'll go to you, Ashok.
Sure, yeah. Especially on-device AI, Qualcomm loves that. But partly because if you look at how the devices have evolved right now, so there's so much of compute capability, inference capability that's being built into the devices. And even from an LLM's point of view, we talked about that quite a bit. And in LLMs and RAN, you can say what the application there is, but just talking about the compute that's being baked in, we're able to support up to 10 billion parameter kind of LLMs or SLMs, depending on what you call that at that point. They're all supported right now on UE.
And we use them for photos and use these things like photos and cat video.
So that's the starting point. But then you do have this kind of inference capability that's sitting on the device. This, apart from ML cores that are being integrated into the modem, which is also doing some very specific things. So the capability exists right now. And if you look at, eventually, what are all the benefits of AML? And so we've talked about maybe at the network level performance improvements and things like that. But then even at the user level, there are going to be things like privacy was touched upon, immediacy, low latency, wherever that becomes important, personalization. Personalization, of course, from an application point of view, it's very clear what personalization means. Taking a picture. Now, how would I take a picture?
Taking people out of the picture that you don't like.
Pick people out of picture, or someone else is talking about an application where, I want to write this memo as if I'm writing it, not as if, 1,000 other people would be writing it. So that level of personalization, all those things become important. But then, then what's the relevance at the RAN level? So even, as we look at how do we get the most out of AML? Because as we talked about, most of the algorithms, if you just look at a more general setting, then we know how to solve those problems. We have algorithms in place. If AML can really bring any benefits about the personalization, even from the context perspective, where are we sitting right now? How do the network conditions look like? Maybe that's going to be different for me versus someone out there on the streets right now. And how do I take that into account? And maybe I'm sitting here for the next half an hour or 45 minutes, depending on how the questions go. And then based on that, can the device and the network make use of this? And then they'll do something for me versus...
So the UE knows you're in a panel. It's going to shut you down because you're not going to use your phone when you're talking.
Yes.
Right? And save power.
There you go. Not going to move. So not use my uplink resources for reporting CSF
exactly.
and other things. It's probably not going to change too much. But then I guess the main point here is the device capability is going up. And it is important to start making use of this device capability. And partly it's also becoming a requirement because when as you look at how the AML framework is coming together, and we talked about 3GPP and cross-node AML kind of functionalities where there is a little bit happening on the device, a little bit happening on the network. And because you have these two entities that are talking to each other, and not in terms of the physical parameters that we understand, but maybe some latent information that's going across the network, that's where we're able to get the benefits.
That's fair. And it's got environmental information around with you as well.
Exactly.
And also,
And that's also where, with this latent information, you can also capture other functionalities as well, not for the very specific use case that you're talking about, but the other functionalities that come in. So the key is that the device is actually able to start doing some of these things.
Useful. Shalka, anything to add to that?
I would add another dimension to it. So, example, both device and network contributing to building powerful AI models. So, let's say quality of experience. With the new type of traffic like XR, VR, it most doesn't apply anymore in a traditional way. Your speed test is not going to determine how well your network is doing, which many operators are still relying on. It scares them, but it doesn't really do good job.
So signal test is no longer active.
Exactly. So then, for example, to really build comprehensive model, you need to know how is device doing. So if we can get from device information on specific to applications running on device, which can contribute to data like kind of Okla or Cell Rebel type of data being sent somewhere and merge with network stats, meaning how is network doing? So therefore, then you are kind of merging those KPIs and creating much more comprehensive model of behavior. And then let's say you can use device to build your network, and then after that, you just rely on network deployed model to figure out what's the quality of experience, or vice versa. So that type of interplay is also important and interesting.
Yeah, that's interesting. I think I think those are all interesting ideas to explore, and I think that's hopefully an area of exploration. Next year we'll talk more about that. So that'll be new next year, I think. So we'll see. But moving right along. So in terms of the architecture or the framework, do we expect a diversity of sort of platform architectures, or do you expect to have one or two models? I'll give you an example, right? One example of sort of AI in RAN, or even the RAN architecture itself, is we've gone down the argument about splits. We've talked about CPU versus GPUs versus ASICs versus FPGAs in the past, right? Do we expect one or two dominant architectures for the AI native RAN as defined by Kiran, right? Or do we expect a diversity of different approaches as we explore this? And I'm going to direct this question. You can pick it up, or Udayan can speak first, depending on who touches.
I think there is always going to be a diversity of choices, and choices are good. May the best silicon win. That's fine. But what is happening is that right now, if you look into, we did a lot of this split architecture, and as you rightfully said, between there's a difference. Yesterday I was with some discussions say how is a 5G actually had any success? Yeah, because it has changed the paradigm that a lot more people are contributing to it. So not only algorithms, I mean, companies like Airas of the world were not even doing anything on the 4G yet. Then you can't even think of it.
That's true.
So a lot more, that is everywhere. That's true. But still we have not done enough. What the ORAN or even before XN has done has opened up the architecture now. You have interfaces well defined. 702 or ULPI, all good. So DU, CU, and all of it. But within DU is still some monolithic elements of it. If a startup company comes up with a very groundbreaking some elements of it that improves spectrum multiplier or others, how do you actually insert that in a product? Unless they becomes a DU supplier or a CU supplier or whatever. So those things are still open up. But from the silicon side of it, absolutely, there'll be diversity of the silicon suppliers. But power, remember, whatever you talk about Cloud RAN, today 100% of vRAN or even the traditional RAN deployment is on-prem. On-prem means literally far edge elements of it, where the antenna subsystem is there. It is not really happening in the cloud because of the other issues, fiber and transmission and all of it. Most of them are happening on the far edge side of it. So you have to meet power, performance, cost, all of those dimensions. So there are more challenges there.
So diversity of silicon is expected.
Right. And don't forget the AI is being added to original workload is still a latency sensitive workload. Workload is very latency sensitive. It's not a throughput oriented, it's not just parallel, processing. There are a lot of interdependency between this module, that module, pre-coder, there are control loops in between. So
just one point.
Go ahead.
Even though there is, yes, of course, the market is going to win and the architecture or the silicon of choice is going to be dependent on the market. But there are some silicon architectures that are lending themselves to AI. Like, for example, ASICs, they're not even updatable. Right? If you want to change things, or FPGAs, they are difficult. So I think for that reason, the infra has moved towards software-based signal processing, and I think that's whether it's software run on CPU versus GPU. I think that's depends on
the architecture depends, right? I mean, if you look at LLMs or some of the transformer models, right? You have the tensor units, right? And TPUs and architecture for AI acceleration, not GPU specifically, AI acceleration, right? For linear algebra. Right? Now, in the RAN, who knows what the model is? I mean, you're not going to use a transformer model, right? I mean, right? So,
but diversity, I mean, you can have a system-wide packaging as well.
Yeah.
You can have some ASIC models. I mean, And I think of it that client, I mean, AIPC stuff, I mean, you can do that. There's an NPU there. There's a GPU integrated. Yeah,
sure.
There are programmable cores. There may be fixed function ASIC blocks there. So,
the game
there are choice. I mean,
but the game is on the die. How do you mix the blocks?
Right.
What blocks do you put in?
What block?
Yeah. How many of these?
How many of these things? Power, performance, and packaging.
Yeah. And then maybe
Kiran and then
Kiran and then Sridhar. Okay, sure. Yeah. So it's in terms of diversity, of course. As you pointed out, first of all, the applications themselves are going to be quite different in terms of even the requirements, and power is going to be a big factor. So NPUs, for instance, is going to also be playing a bigger role. And in some cases, you may have ML models, but even stricter latency requirements, which may have to be much closer to your maybe chip level or sample level processing that's going on, in which case probably has to be some ML core sitting inside the ASIC itself. So starting from that point onwards, NPUs, GPUs. And I guess the other thing also to keep in mind is for most of the ML models in RAN, we cannot afford to just use a model that's just trained on the fly and then release it and see how it does. Maybe in some cases it's okay, maybe not in other cases. So given all of this, the workload itself maybe just inference versus that in itself says that maybe NPUs are good enough for that versus GPUs. So some other cases exactly not doing training. Most training is offline and you're just bringing in the trained models. So that's also
I don't think we're going to see sort of live training and immediate deployment at the far edge
for most use cases of RAN.
That's fair. Go ahead, Sridhar.
So I wanted to make 2 points. One is, so for example, again, Mavenir, for example, is an open RAN company. But so our philosophy is like what we did in the telco space is we put like an adaptation layer where you write your applications irrespective of the hardware knowledge, ideally. And you can have like cross compilers and things like that you write and you map it to FPGAs, GPU, CPUs, whatever. Ideally that's possible. Sure. Now the issue I think when we are looking in the AI era, I think even the definitions of ASICs are changing, in my opinion, because people are putting AI blocks. Like if you take a company like Marvell, so they may put AI within an ASIC itself. So, but it still needs to be programmed, it still needs to be compiled. And I think all the metrics that Udayan was talking about, power, cost at the cell site, I mean, all those have to be met. I mean, there is no way around it. So I think the question is, again, there is going to be a diversity of choices. And, competition is always good and healthy for the ecosystem. And I think, but being able to write or architect your system in a way that maybe can support multiple of these architectures and still be efficient, I think maybe that is the challenge.
That's maybe the challenge. I think, we're sort of bleeding into the challenges that we're talking about and the complexities in RAN. We've covered actually a lot of the sort of talking points that we were supposed to cover, right, in terms of that. I think that's usually the case. And I think, what you're pointing out is right, which is, what's the architecture of your silicon, right? What blocks are you going to put in there? How many of each blocks are you going to put in there? What's your power budget availability, right? And then what algorithm are you going to run? And then the software problem is more complex. How are you going to optimize the software that you use those blocks for? And depending on which silicon and how many blocks of what, your algorithms are going to change to, does the software fit the hardware? Does hardware fit the software, right? Given the time scales you're dealing with in terms of, of hardware, chiplets aside and new technologies aside to try to accelerate those things, you're still dealing with this iterative process that's got some time scale to it. Right? Yeah. And how do you deal with that? I think that's going to be some of the challenges.
And also this repurposing that same compute for something else. So you have concept of, there
are people out there who tell you that your RAN architecture can be used for third-party workloads, even enterprise workloads, and rent it out because CSPs want to make money on the far edge.
Exactly.
Right?
Yeah, maybe it's a new thought, and we may not all agree. But
yesterday, Anand's favorite company, the other talked about that with the RAN, you can run other stuff.
I could be running gaming, right, next to you. As you're doing channel estimation, I will run a game next to you and be safe.
That reminds me of the SETI, the search for extraterrestrial intelligence. Like you had your laptops and
So the question is, so don't shut the RAN down. Don't shut the RAN down. Find ET, right? Don't shut the RAN down.
For example, do you know that in lots of LED lights in cities, there are actual computers running and supporting many applications like parking applications, others. So they're reusing the same platform to have a bunch of sensors on it. It's the same kind of concept.
But there are other use cases. I think as we go forward and we're more comfortable with it, I'm sure then the RAN and the computing can be used for other things over time. Yeah. But I think that will take time.
Yeah,
I think again, network's a little different from the cloud. I mean, the cloud you get sort of isolated, your little containers or your little VMs and all that. On the RAN, generally speaking, you have some amount of capacity. Once you allocate that, someone else doesn't have that, right? You sort of shared resource, and that's one of the problems with not just RAN, networks in general, right? And it's shared network, and I think that's what we're learning. Now, I want to sort of move on a little bit here in the last, 10, 15 minutes and talk about what, aside from the challenges that we talked about here, which is data, right? I mean, I think, who was it? Someone brilliant said that, AI is all about data. I think it was Sridhar. Maybe, I don't know.
No, Sridhar.
Not Sridhar?
Sridhar.
It was Sridhar. Sridhar. Yeah, see, we all agreed on that. I was very back. But speaking of the data challenge, right? Quality training data. I know Ravi's torn his hair out. You see, he's still got a lot of hair, but he used to have a lot more hair. How do you get data from the carrier, right, for the AI training, right, in a way that's privacy preserving and compliant, right? And that's always a challenge. And synthetic data, maybe it helps, maybe it doesn't. And so, given the AI native RAN is dependent on data, how do we address this need for quality training data while still preserving privacy and keeping, Ofcoms and FCC and everyone else happy? We'll give you that really easy question.
You also already hinted on some kind of parts you need to do. Like you need to be able, if you get data from operator, you need to be able to anonymize it properly. PI, location, there's various methodologies how to use it. Of course, you need to use synthetic data too, or you need to augment it. And you can use generative AI, which we use a lot in these discussions, to create a generative new data, synthetic data. But in general, also those kind of alliances help to understand how to create those data sharing frameworks and how to make it safe. So, for example, I'll just use one vendor, and I'm not endorsing them, but I'm just saying, let's say Snowflake is one kind of platform which creates this data fabric which, you don't have to share. You don't need to move the data. You can use this kind of concept the data resides, but governance and operation on top of this kind of single pane of glass allows you to do this kind of operations. So it eases the way how you share the data, and there's certain kind of accepted algorithms. So I don't know, like if Alliance creates some kind of anonymization module, then everybody should trust it because it's been tested through several companies. So it's not like, oh, Ericsson did it. Do I trust them that they anonymize it properly or not? So I think this type of initiatives really will help. And just understanding that partnering is the key. Because like if everybody just sits on their data, I think, oh, I have this pot of gold. I'm not going to give it to anybody. I'm just like, keep it because it's really very worth it, but I don't know what to do with it. That was plaguing us for a long time. So I think if we just agree like, okay, I can do this much with data, you can leverage on top of that something else, then at the end, we all benefit. So I think that would be the key.
I think that's critical because if you look at other areas of AI ML, right, you have Kaggle, you have all the competitions, you have open data sets. And the open data sets drive innovation because other smaller companies, other people can actually use the data set. And without the availability of a common data set, it's very hard. Like if you look at, like computer vision and image recognition with AlexNet and all these other sort of competitions, but sort of academic competition, you have a repository of data, right? You have a data corpus, and that's available to everyone, and that drives innovation. And so to the extent that we can achieve that, for the RAN in different scenarios, right? Test it in a large event scenario, test it in a whatever, that would be great.
Couldn't agree more. I love the ImageNet analogy because that's what's needed. And having been in the trenches trying to develop some of the algorithms for layer one work, yes, synthetic data is great. It's great to get to like a version 0 of your AI based algorithm. But the moment you start working with a real operator or a real equipment manufacturer, you'll know that there is RF impairments, there is frequency drifts and timing offsets. All of these change the way the data looks, and your AI algorithm needs to compensate for that or handle it. And the way specs are written in 3GPP versus how they are actually used is also different. So coming up with, hey, these are the 5 dominant ways of how, let's say, a least square channel estimate is going to look like. And we welcome startups or even grad students.
Grad students,
to
right?
come up with solutions.
Because you can write a lot of papers on that. Many PhDs can be minted because of that.
So, so I have a slightly different view on that.
Oh, good.
See, my opinion is we need to have common metrics for benchmarking for data. And I think there are multiple reasons for this. I think one is, like if you look at even 3GPP, for example, they came up with channel models. Like even though every channel engagement is different, but at least it gives you a way where multiple companies can come together and they can all refer to, okay, if I run my, I don't know, PRATch detection algorithm or something, or my channel, I know on this channel environment. So that way I can filter out a lot of noise. See, today what's happening is, first of all, the numbers are all over the place because there's no standard benchmarking. So one company can come and claim I have 20% efficiency because of AI, ML, energy improvement. Another company can say 30%. And then an operator looks at, oh, he's seeing 30%, but it may be in a completely different scenario. The load may be different, the environment. So there is no reference to benchmark. So that is issue number one. Issue number two, look at it from an operator perspective. And I'm not an operator, but I can easily visualize the problem. If I am a company that has some innovation and I want to go to an operator and I say, I've done this AI ML, I can give you 20% improvement in spectral efficiency. I'm just giving an operator say, very nice. How do I validate it? Oh, I need to bring you in my lab. I'm going to do a trial. Even in the lab, I'm not sure. Then I have to deploy it in the field. So that's the 2-year process in most places. Okay, it's a 2-year process. Now, the challenge is if there was a way where, even if there was a reference benchmark, it may not be an optimal, well understood thing, but it can actually, you at least know I don't even want to go and bother an operator until I have at least met that minimum bar. Then the operator also feels happy. Look, at least, there is this baseline stuff. I mean, like just like in 3GPP, if you take the 38 series for EVM, there is a number. I mean, the numbers are very loose, like, 16 core has, certain percentage. So the numbers are loose, but at least, don't even bother coming to me unless you have fed that kind of. I think this is where I think is missing.
So that's, I agree. So I think one of the ways that could be potentially achieved is almost like a double blind kind of a scenario, right? Where this data sets created by either operators or equipment manufacturers and nobody knows where this came from. And let's say a particular startup is able to smooth this channel or able to achieve a particular result with this channel. So whoever put in the data will know, okay, they are solving my problem.
There's like some of those Kaggle competitions, right? Which is, I give you the training set, so it's not training set, but a set that you can test with. If you don't pass the benchmark, don't even bother, so waste our time.
Yeah.
And then after you go in there, we'll run it against another set, the other half, right? And we'll see, who wins, right?
Yeah.
No, on this data set thing, right? Again, so I'm part of the ORAN Alliance. So I actually around 2 years ago, or 1.5 years ago, I went and proposed that the ORAN Alliance take and they have become. But it's not as simple as this thing. First of all, it's very hard to get data from operators. Even anonymized data, it's very hard to get it from operators. So issue number one. Issue number two, if you let it open to the community to contribute, I mean, people can put anything they want. So who's going to police and who's going to say, I will take this data set and not that data set? So it almost becomes like a government problem. I mean, who actually is going to be fair and unreasonable?
So the problem is if you boil the ocean, no progress will be there.
Yeah.
I think I'll go back to what she said, the partnership. Yeah. We had no problem getting the data from operators, by the way. In February, we showed 3 different AI-specific stuff in MWC. One is with Vodafone, one is with Deutsche Telekom, and one is with AT&T. In all the cases, they provided the data. They said that, okay, this is the 15 minutes worth of data. Now you can replicate this way.
Yeah.
They looked into it and said, okay, now you tell me how your load line, how you're tracking this. So you can get that and then anonymize it. But if you're trying to get a standard for everybody progress is very slow.
Yeah.
What Sridhar said is very true.
We just need to find a country where there's no privacy and the government gives you the data and say that's great, right?
Not
But that will be
necessarily.
very specific.
Not that
to
everything
country.
will happen in
You can
China.
take those
That's
models
true.
to different countries. So
different terrain, different
terrain. So
different, exactly.
Right.
then I think, going back, eventually the synthetic data will have a huge role to play. That's going to be the starting point, and it can be made very rich. Synthetic data with Gen AI models and digital.
You can add impairment. Right?
You can.
We use a lot of system
And you can
simulation.
specifically simulate situations you want, like hand over this.
I think, like Ravi said, there's going to be weird things that you didn't account for.
For sure.
And
But you have a starting point.
And that's a layer of personalization that you have to bring into your own implementation to the set of vendors that you go to work with. Because so what I'm trying to solve for, at least for the startup community, is that 2-year lag that Sridhar.
No, I agree.
If I can solve or clean up the data, and at least either an operator or an equipment manufacturer knows that what the clean data looks like, and if a startup can achieve it, then if we can cut out this mode where, I don't really think that this works in my setup because that's the data I really solved for, that'll be great.
I think
You should have had the operator in this panel.
we should have had an operator. We'll see. We can pick some volunteers.
Yeah.
Right.
Yeah, but I know I think I sort of like where we went because it's a little slightly different from all the other panels we had, right? And I think it's important, which I think we all agree, that AI native or multi-RAN or hybrid is important, but AI is fundamental, right? As defined by Kiran, the AI native RAN. We have recognized that data is critical to making the AI portion of the AI native RAN work, right, really well. We recognize that there's a lack of data, the data diversity and open data sets are going to be important to the community, that we want to achieve that. I mean, the last question was, what would you say to sort of startups and other people to encourage them? I think fundamentally we've come to the conclusion, which is we got to get you the data, we got to get you engaged, right, somehow, to cut that 2-year cycle down to 6 months or better, right? Right? I think that's...
So, I'm also part of the Open RAN lab that Boost Mobile is sponsoring. So, as part of the NTI, but I think one of the things that the US government is trying to do is also start up all these labs where people can go and validate technology. And so the US government has invested, I think, $140 million on this topic, at least as part of NOFO 1. So I think that could also be a good avenue.
Yeah, I would say, push the MPIA to create data sets that the startups can use, PhD students can use to get get their PhDs, right? And everyone gets benefit from that, I think. And then we can save Ravi's hair because, I know he's complaining many, many times in the past, I wish I could just get data sets for a while now, right? And I think it's not just Ravi, but any other startup out there.
It's not just startups.
Yeah, it's not just startups. Yeah, Ericsson, biggest Ericsson too, right? Presumably.
But it's all about this, contractual.
I'm
What do you think where gold is?
Yeah, I think we can work
A
out
lot
ways.
of times you may have one side of the data was the other side, and you may not have.
Yeah, you have the UE stuff, right? Yeah.
Yeah.
But we got to start somewhere. We have to start somewhere.
Start somewhere.
We have to
It has
start
to be over the air. I mean, three of the folks sitting in the panel have over the air setups.
Yeah.
It doesn't need to be operator data.
And that's actually a very good point. In some of the stuff that we're working, we have a network that is running in Jones Farm campus that we
Okay, four of the people on
which
the
is
panel.
basically private network, complete packet code. They are generating data.
Yeah, that's true. That's true.
How will that reflect to a data set for a Reliance Jio in Mumbai? That's a different story.
Agreed. But I think as we learn over time and you characterize the data, we'll learn more. Synthetic generation will get smarter and better. Impairments will become creation of impairments or possible impairments will become smarter, right? And now you have synthetic data that you can use that if you pass the test, then you have 95 or 99% probability or certainty it will work well in an operational RAN, right? Most of the time. In fact, that's what we want to get to because that reduces the speed, that reduces the cycle time of innovation, and that helps. I think that's what we're after. So, all right, with that, I think we're at time. So I want to thank the panel for your lively discussion and the fact that you didn't make too much trouble. Appreciate that. But good trouble. There's good trouble and there's bad trouble. You only made good trouble, so thank you. But let's put a...
For bad trouble, look towards there.
Yeah, I understand.
Next time, put him in the panel.
Yeah, so... we can take questions or we're a little over. Oh, God. Okay. Yeah, that's okay. So I think let's go ahead. Yes, Yogesh, you go first.
So I have one question, whether AI native or otherwise. My question is that the holy grail for RAN is that we have put a lot of adaptations on a link between years where it's like the SAN and theory, transmitter receiver, right? We put a lot of adaptations on a link. Can AI set that why that link had to adapt in the first place? What happened? So, we use power, we use hard, we did MCS, now we are giving everybody, big MIMO, like a big pipe, I was talking to your ear, right? Long pipes, right? That's MIMO in my mind. But why that link had to adapt in the first place? If you can solve the AI as an operator, I launched all the iPhones in 80. I took that bull by the
So
I can tell you that is one of the foundational answer for $80 billion of spectrum spent. Why?
Yeah. So that is again I can give you a view of at least our product. So we have something called causation. We have network intelligence as a service as a product that we sell. So the idea is that AI is all about data. So if you are able to capture the data that can lead you to tell you what exactly happened in the environment, you can extract the data, learn from it. You can actually tell, and it can help you tell, for example, even when you're doing all the SON work and all the analysis, the whole idea is you're able to look at all the data that is coming and look at past history, look and to train your models based on that. So you can actually tell under these conditions, I see these parameters changing as I'm pulling all the data, the PMs and traces and logs and stuff like that. And based on that, I can tell if something bad happens at this time, I can tell that, it because of some of these things happen. And I have a very good idea because you need that based on my domain knowledge. I know, for example, that RSRP was bad at that time. And so when I saw this KPI degrade by this time, it was because, this issue particularly happened at this point in time. So, you will not be able to get every single data accurately. But remember, AI is all about statistics. So if I can get you some kind of, maybe 85% of the time, maybe you may be right, maybe 80% of the time you may be right. But you can be better than going all over the place and not having any clues. So I think
that product
So maybe
right?
yes. If I were to say one thing, why adaptation? That was the original question. All the adaptation because of $80 billion that's spent. Because of all the money that's spent, you want to get the most out of every dollar that was spent, which comes down to the spectral efficiency, network efficiency.
Questioning once I adapt. Why? You hear base station, we adapt. We create unnecessary noise on this pair of base station.
Yeah.
So they adapt.
Yeah.
So that is another.
It's a multi-scale problem, but then there are solutions for that. That's the point, isn't it? There are solutions.
The solution is that every link adapts.
Every link adapts, and
Then overall on operator, every link adapts unnecessarily without flowing that line the first place I need. No. So you adapt and fix our way. We said everybody is adapting and everybody's
hopefully everyone's throughput is going up and not down. Because if it's all going down, then that's...
So then I will give my own to everybody. Then everybody will use more power and then we worry about energy consumption. I mean,
I think the systems do have global optimization, and I think we can talk about that. Sridhar will be very happy to answer your questions.
because you're the product.
Yeah. So after that, you
guys go on.
Yeah, he's staying orders
Let's
outside.
take one more question and then we'll wrap up. I think you next. Yeah.
Good. So, National Science Foundation has a lot of wireless platform forward. I think that have one in NC State University, Iowa State University. So, speaking about data, I'm wondering, could those platforms be used to generate data for your AI and work?
And I hope we haven't tested every one of these platforms. We have talked to a couple. What happens is a lot of these platforms are not ORAN compliant. They're not 7.2 splits. They're sometimes not even IEEE compliant. Right? So they have set up systems. A lot of these systems are sometimes set up more for running kind of RAP level automations and network level automations. It's not necessarily easy to get like physical layer data out of them. But I'm hoping that there are some out there. We haven't exhaustively searched. There are some out there where we can get data out. The second thing is about the stack. What stack are they using? How do I tap that data? Usually, they themselves don't tap the data. And even if you go and ask them, can you give me like layer 1 data? They don't necessarily know how to tap that data and put it out there because it could be running a hardware, it could be running ASIC. Data might be inherently untappable.
Yeah.
There's some issues. I'm hoping that there is a system-wide solution, but there could also be a market-driven solution. NSF is one approach, government-side approach.
Yeah.
The other approach could be any company who wants to achieve spectral efficiency improvement from third parties can put data sets out and say, we are solving this internally, but if somebody else can solve it better than what we can, then we can collaborate with them. Yeah. That is also...
And there's a lot of ways of, trying to get data. You can go to a university and say, I'll give you free mobile access for 6 months if you use this, but you opt into your anonymized data contribution to a pool, right? There's a lot of ways to do things like that in return for something. You get Netflix for free, right? Or whatever, right? But then now you skew the population because everyone's using Netflix. But anyway, I think there's other ways of doing it. So with that, I think we're a little over time.